Okay, welcome back for our final module, really, for the entire class. This is Module 9B. We're doing the second half of capital budgeting. In the first half, we covered payback and net present value. In this module, we're going to talk about the Profitability Index and the internal rate of return. Now, the Profitability Index, I'm going to start off by coming to the second bullet. I think the Profitability Index is really stupid. It is not something that most companies do. One of the reasons why I'm talking about it here is I'm talking about it for the same reason I talked about it in corporate finance. Some of you were in corporate finance and you remember the reason why I cover it. It is because whatever society it is that accredits our actuarial science major, they have talked to me and they ask me, point blank, do you teach about the Profitability Index? And my answer, it's an obvious question. They want to know if this is being covered. And so I'll tell them, yes, I cover the Profitability Index. I think it's really dumb, but I do cover it. And so I'll tell you why you'll see why it's dumb in just a minute. The Profitability Index of an investment is the present value of the inflows divided by the present value of the outflows. Now, you got to change the sign on the outflows so it's not a negative number. But if the Profitability Index is greater than 1, you accept the project. If it's less than 1, then you don't accept the project. So I'm going to go ahead and take those cash flows that we figured at the end of Module 9A. So we have a $430,000 cash outflow, but then we have cash inflows of $170,000, $160,000, $150,000, and $218,000. And so if we add it up, the present, if you would plug it into Excel, the present value of our inflows is $548,371. I'll show you how I did that on the next slide. And the present value of our outflows is negative $430,000. Why? Because in time period 0, a dollar is worth a dollar. If I ask you, how much money do you have in your pocket? And you say, I got $5. Well, how much is that $5 worth? Today? Yeah. Well, $5 is worth $5 today. Now, as of yesterday's money, it's worth a whole lot more than money than money tomorrow, but it's worth a whole lot less than money yesterday. But in time period 0, a dollar today is worth a dollar today. So therefore, the present value of the outflows is $430,000 negative. So let's go to the next slide. So what I did to find the present value of the inflows was I used the same net present value Excel workbook that we used before, but I just took out the negative cash outflow in time period 0. And with a cost of capital of 10%, then our net present value is $548,371.01. I just took out that negative cash outflow from time period 0. So I take the present value of the inflows, the $548,371.01, and I divide that by the present value of the outflows, making sure to change the sign from a negative number to a positive number. So I divide that by 430,000. And the Profitability Index is 1.2753. And so because it's greater than 1, we accept it. Now, why do I think this is a dumb method? Because by the time you've done the present value of the inflows, by the present value of the outflows, you've already, before that step, you had enough information to calculate the net present value, which would tell you if you should accept it or reject it. All you're doing this time is you're taking one extra step to take out the present value of the outflows to try to find the present value of the inflows, and then you divide it. It's just a dumb method because you're taking more steps than you really need to. But be that as it may, some people may still be using the Profitability Index. I've never run into anybody who does, but apparently the folks who accredit our actuarial science degree want to make sure that in the finance classes we do mention this thing called the Profitability Index. So consider it mentioned. But if you use the Profitability Index in the future, I think you're dumb. Okay, let's move on to the next slide. The fourth method is the internal rate of return, or IRR. Now, you might remember that there was a slide in Part A 9A that had this area that I've got circled here. You would accept a project that has a positive net present value. Why do we accept the project? Because it means that the rate of return exceeds the hurdle rate. So that if your hurdle rate is 10% and you have a positive net present value, that means that the guy who's jumping over the hurdle is jumping higher than that hurdle, obviously. So if you picture a person jumping over a hurdle and you measure from the top of the hurdle to the bottom of the guy's feet, there's a positive distance there. That's like the net present value. So if the person is jumping over the hurdle, then obviously the rate of return on the project is higher than the hurdle. So you go to your boss and your boss says, hey, should we do this project? And in the first case I mentioned, you just tell your boss 2.22 years is the payback. Well, I didn't ask that. Should we do it? Will it be profitable for us? So you march back to your little cubicle and you figure out this thing called net present value. And so you go back to your boss and you say, yes, we should do it. Why should we do it? Because I've calculated the net present value and it's positive. Well, so we do it because it's a positive number? Yes. What does it mean that it's a positive number? When you have a positive net present value, that means that the rate of return on the project is higher than the cost, the K sub A of the project. And the boss goes, oh, well, that's good to know. Okay, well, what is our rate of return on this project? And you say, I don't know. All I know is that the rate of return is higher than the hurdle. So what we're going to learn now is how to calculate that internal rate of return so you don't look dumb in front of your boss. So let's go to the next slide. To calculate the internal rate of return, or I should say not to calculate it, but another definition of the internal rate of return is that rate of return which, if you used that rate of return as the average cost of capital, it would bring your net present value to zero. Now, just picture with me a person jumping over a hurdle, and then he's frozen in place right above the hurdle. Well, obviously, there's a positive distance between his feet and the hurdle. Well, now, how high is he? Well, imagine if you gradually raise that hurdle, gradually raising it until as it's getting closer and closer to his feet. As it gets closer and closer to his feet, the net present value is getting smaller and smaller until finally the hurdle touches the bottom of his feet. At that point, the net present value is zero, and by definition, that is how high he's jumping. So the internal rate of return has this definition, an alternate definition, that the internal rate of return is that rate of return which, if we use that as our average cost of capital, the net present value would be zero. And the reason why I mention that is because the way that your financial calculators work and the way that Excel works, in order to calculate the IRR, what Excel is doing is it's gradually raising that hurdle rate higher and higher and higher until the net present value is zero. Once net present value hits zero, it knows to stop, that is the rate of return of the project. So let's go ahead and look at the next slide. In order to calculate the IRR via Excel, that is even easier than calculating a net present value. And you thought the net present value was pretty easy. So here in cell D8, I typed in IRR equals, just so that the person would know that in the cell to the right of that, in cell E8, we're going to actually put the internal rate of return. To calculate the IRR, you just simply type in equals IRR, and then you put in a parentheses, and you notice the only thing that is highlighted is values. You can ignore that where it says guess. Okay, let's go to the next slide. And then all you have to do is highlight all of the cash flows. Remember, with net present value, you didn't include cash flow in time period 0. With the IRR, you do. You highlight all of the cash flows, and then you put a closed parentheses around it, and then you hit enter. And when you do, you're going to get a 21.74% internal rate of return. Now you may need to convert the formatting of the cell to be a percentage and make sure you go at least 2 places past the decimal. So when you go to your boss and say, we should accept the project. Why? Well, because the net present value is a positive number. What does that mean? Well, that means that the rate of return that we're getting on this project is higher than our cost of capital of 10%. And the boss says, oh, really? Well, what is our rate of return? And you can turn and look at your boss and say, we're getting 21.74% return on this investment. And your boss goes, excellent. I promote you and I'm doubling your salary. I kind of doubt that. Now, if we only use internal rate of return, you've never heard of the net present value, you've never heard of profitability index, the only thing that you know how to calculate in your life is the IRR. Should you accept or reject this project based upon the IRR? Well, obviously you would accept it because your rate of return is 21.74% and the money is costing you 10%. Now, a couple of things to note. When your IRR is greater than your average cost of capital, the net present value will always be a positive number. It's like saying if the rate of return, if a hurdler is higher than the hurdle, then there will always be a positive distance between the top of the hurdle and the bottom of the guy's feet. You say, well, that goes without saying. I know. But if I throw a question like this on a test, if IRR is greater than the average cost of capital, then the NPV will always be positive, true or false? And the answer, most students go, well, I always answer false when the question says always. No, it will always be positive. When the IRR is less than the average cost of capital, that is the bottom of the hurdler's feet is below the top of the hurdle, then the net present value will always be negative. You will never get mixed signals. In a sense, you'll never get a mixed signal of saying where net present value says accept and IRR says reject. You'll never get that. You'll always get the same signal from net present value and internal rate of return. That is not to say, however, that there is not such things as mutually exclusive projects. Mutually exclusive projects are those projects where you can either pick one or the other, but you can't pick both. For example, you may have a project where you're thinking of either bulldozing the administration building or refurbishing the administration building. Both projects may have a positive net present value, and both projects will have an internal rate of return that's higher than the cost of capital. But you can only pick one. You can't say, I think we ought to destroy it and we ought to rebuild it. That is what's known as a mutually exclusive project. And earlier, in an earlier slide, I said almost always accept every capital project for which the net present value is positive? Well, here it is. We've got 2 possible projects: tear down the administration building or refurbish the administration building. Both may have a positive net present value. This is the case where you almost always accept every capital project. In this case, you can't. You can either pick one or the other. Now, when a firm should choose all projects that have positive net present values except for those that are mutually exclusive. I love this little sign here on the left. This is cleaning your house and watching your kids is mutually exclusive. I love this sign. Cleaning with kids in the house is like brushing your teeth while eating Oreos. It just doesn't work. So let's go to the next slide. So if 2 or more projects are mutually exclusive, tear down the administration building, refurbish the administration building, then which one do you choose? You always choose the one with the higher net present value. Now, usually the one with the highest net present value will also have the highest internal rate of return, but not always. I mean, you'd just think that that would be the case. The one with the highest net present value, if alternative A is tearing down the administration building and alternative B is refurbish it, you would think that for alternative A, if our idea is to tear it down, the net present value of a tear down will be higher than the net present value for alternative B, and the internal rate of return for alternative A will be higher than alternative B. but that isn't always the case. If you want, you can go ahead and plug this into Excel. In fact, go ahead and do it. Go into Excel and put these cash flows. We have Project A and Project B. They each have an initial cash outflow of $10 million, and Project A has the following cash flows. In year 1, $1.5 million, year 2, $2 million, $2.5 million, $5 million, and $5 million. Project B has a $10 million cash outflow with a $9 million inflow, $3 million inflow, $1 million, 2, 0, and 0. Now, assuming we're using a cost of capital of 5%. If you plug these in, you'll find that the net present value, if we were choosing a project based on net present value, we're going to pick A over B, because A has a net present value of $3,433,000. B has a net present value of $2,329,000. But on the other hand, Project A has an internal rate of return of 14.33%, whereas Project B has an internal rate of return of 22.49%. What's a mother to do? Which one do you choose? I'm getting mixed signals. And the rule in finance is always pick the one with the higher net present value. You ignore the internal rate of return when it comes to mutually exclusive projects. Now, why are we picking the one with the higher net present value? We're doing that because of what's called the reinvestment assumption. The reinvestment assumption, when you're calculating using Excel, calculating the net present value and the IRR, when you're calculating the IRR, Excel is assuming that every year when you get a cash flow, that it's going to be reinvesting that cash flow at the internal rate of return. So let's say that you're coming up with an internal rate of return of 20%. Well, you're assuming that in the first year when you get $100,000 inflow, you can turn right around and invest that in something that's going to get another 20%. And the next year when you have a $200,000 cash inflow, you can reinvest that at 20%. On the other hand, when you're calculating the net present value assumes that you can reinvest your money at the cost of capital, which is much lower. It's a much more conservative number. Since we're investing in progressively less profitable investments, we've already invested in Project A, and when we get cash flows from that project, where are we going to put that money? We're going to take those cash flows and we're going to invest them in maybe Project B or Project C. There is no way on the planet that we're going to be able to take the cash flows from that project and reinvest them at the same kind of return we got for that project, because we always pick the highest return projects first to invest in. So it's unrealistic to assume that future cash flows could be reinvested at that rate. And so we can't use the internal rate of return as our reinvestment percentage. And as I said, using the net present value, we're making a more cautious and conservative assumption that each of our cash inflows could be invested at least at the cost of capital. Now, at this point, some people who are thinking about it may say, no, well, what if you can't invest your money at the cost of capital? And the answer is we can always invest our money at the cost of capital. And you say, how's that? Well, if we don't have any projects that we could invest our money in at least at that rate, let's say that we've invested in projects A, B, C, and D, well, at least we can take the cash flows and we can retire some of our debt, we can buy some of the stock out of the market, etc. So basically, we're avoiding having to pay our cost of capital, which is the same thing as getting the return on our cost of capital. So the more cautious assumption is to assume that we can reinvest at the cost of capital. All that to say just one simple thing. If you do have mutually exclusive projects, and if you get mixed signals where on one the net present value is higher than the other, but with the other the internal rate of return is higher than the first, you always go with the highest net present value. Now, why is it that we sometimes might get mixed signals from net present value and IRR? Maybe that thought was crossing your mind. Why is this happening? And as I say here, I thought you would never ask. Now if you have that information plugged into an Excel worksheet, go ahead and change your cost of capital to 10%. And when you do that, you'll notice something interesting happens. Now, when you change your cost of capital to 10%, we don't get mixed signals anymore. The net present value for project B is higher than the net present value for project A. The internal rate of return for project B is higher than the internal rate of return for project A. So you're not getting a mixed signal anymore. Something happened between 5% and 10%. What happened? That happened because the average cost of capital moved to the right of something called the crossover point on the net present value profile. The net present value profile is a graph, and I'm going to show that to you next. So to calculate the net present value profile, we have to create a graph with net present value on the vertical axis, that is the y-axis, and we'll put internal rate of return on the horizontal axis. And then what you do is you run your numbers again with a zero cost of capital to find out what our net present value would be with a cost of capital of zero. Okay? So if you look at this, our net present value at a cost of capital of zero is $6 million for project A and $3,200,000 for project B. Let's go to the next slide. So on this slide, I've just transposed that graph, or the table in which we calculated the net present value at a cost of capital of zero for both. And what we do is we go all the way to the left on the horizontal axis. We're assuming the IRR, and therefore the cost of capital is zero, and then you go straight up. Project A has a $6 million net present value, and project B has a $3.2 million net present value. Now, if you want to know a little hint, if you want to calculate the net present value for a project at a cost of capital of zero, all you have to do is add up the cash flows. Try that with project A. Negative $10 million plus $1.5 million plus $2 million plus $2.5 million plus $5 million plus $5 million. You add up all those numbers, just add them, and that comes to $6 million. Same thing for project B. When you have a cost of capital of zero, then there is basically no time value of money. So we'll plot the net present value for project A is $6 million and project B is $3.2 million. Step 4 is now to take the internal rates of return of these two projects and to plot them on the x-axis. For example, the internal rate of return for project A is 14.33%, so we plot that, and also the internal rate of return for project B is 22.49%, so we plot that. Step 5, we just connect the dots. So you connect the $6 million net present value with a 14.33% internal rate of return for project A, and we connect the $3.2 million net present value for project B with its internal rate of return of 22.49. Where these two lines intersect, if you go straight down from there, where that red dot is, that is what's called the crossover point. And that is where the net present values are the same for both. Because you'll notice for project A, with a very, very low cost of capital, let's say that we're at 1%, so we're very close to the origin. If our cost of capital is 1%, then project A's net present value, the blue line, will be above the black line, the net present value for project B. But as you increase the cost of capital, as you go further and further to the right, the net present values get closer and closer together until at that intersection point, the net present values are exactly the same. But then, after we pass that crossover point to the right, you'll notice that the net present value for project B is higher than the blue line, the net present value for project A, and always the internal rate of return for project B is higher than project A. So we stop getting that mixed signal. Another way that you can actually determine what that crossover point is to create a project delta. So here I've just put side by side project A and project B. and you subtract one from the other. Negative 10 million minus negative 10 million is 0. It's not negative 20 million, it's 0. So you take a negative 10 million and you subtract a negative from it, which is the same thing as adding 10 million, you get 0. 1,000,005 minus 9 million is negative 7,500,000. 2 million minus 3 million is negative 1 million. 2,500,000 minus 1,000,002 is 1,000,003. 5 million minus 0 is 5 million. 5 million minus 0 is 5 million. So now we have a hypothetical project delta. And all you have to do is just plug in those numbers and find the internal rate of return for that project delta. And so once you do that in Excel, you just plug those hypothetical cash flows in. 0, 7,500,000 negative, 1 million negative, 1,000,003 positive, 5 million positive, 5 million positive. It really doesn't matter what your cost of capital is. Plug in any cost of capital that you want. The net present value is unimportant. What we're looking for is to find the internal rate of return. And you'll find that the internal rate of return for this hypothetical project is 9.324%. What that means is this. Go to the next slide. So what this means is if we are using a cost of capital of less than 9.324%, we will be to the left of that green intersection dot. And at that point, we're going to get mixed signals because the internal rate of return for project B will always be 22.49%, and the internal rate of return for project A will always be 14.33. So the internal rate of return for B will always be higher than the internal rate of return for A. However, if we're using a cost of capital that is to the left of the crossover point, notice that the net present value of project A is higher than the net present value for project B, that black line. If we use a cost of capital that is exactly 9.324%, we're going to get the same net present value for both. And then, if we use a cost of capital, K sub A, that's greater than 9.324%, the project will, with the higher net present value, will also have the higher internal rate of return. So you notice here that the black line, project B, that's a higher net present value than the blue line of the internal rate of return, or the net present value for project A. And at the same time, the internal rate of return for project B, 22.49, is higher than the internal rate of return for project A. No more mixed signals. So that's how you can find that. Don't be surprised if on your next test you find a project in which you actually have to calculate what that crossover point is and maybe even explain what it means. Now, one final question that you may have been thinking about. When we used the example with a 0% cost of capital, you notice that Project A had a 14.33% internal rate of return and Project B had a 22.49% internal rate of return. When we changed the cost of capital to 5%, you'll notice that in the upper right-hand graph, or table, that the internal rates of return were again 14.33 and 22.49% respectively, even though the net present values changed above them. And then when we changed our cost of capital to 10%, you notice the internal rates of return stayed the same, but the net present value changed. Why did the internal rate of return always stay the same? And I have that here as an explanation. Think of a hurdler. If the height the hurdler jumped is the IRR, and the height of the hurdle is the average cost of capital, think again of a person jumping over a hurdle and then freezing in place. We're trying to measure how high the bottom of his feet are from the ground. Does it matter how high the hurdle is? Does that change how high he is above the ground? Not in the least. You can make the hurdle above his feet, below his feet. You can take the hurdle away. You can say it has a 0 height. But the height that the jumper is jumping is always the same. and that's the internal rate of return. So it doesn't matter what the cost of capital does, the IRR for that project will always be the same. And that's all I've got for Project 9B, and basically we are done with the course. Now all we have to do is do some theory review problems, case studies. We're going to do a comprehensive problem taking into account average cost of capital and capital budgeting all at once. It will be very similar to a problem you'll have on your final exam. And then the final exam, and it's all over for you, okay? So I won't be able to say I'll see you on the flip side. No more recordings after this.